G'day there. You're watching the Aussie BIM Guru, and today I've got a great video, probably one of the first ones of its kind out there, which is going to show you how you can use Dynamo and Python in Revit 2022 to take advantage of the API sketch upgrades, which allow you to put internal loops inside floors when you create them. This is a feature we've been waiting for a long time, and you might have found that when you opened Revit 2022's Dynamo, creating floors with multiple curves still doesn't work using the standard node. In this case, you will actually need to write some Python to access this new feature. Having said that, I have no doubt that the team over at Dynamo is probably working on updated nodes to support this, as well as the same when it comes to ceilings, which are another new, very similar element we can create, using the same workflow, essentially, but just replacing floor with ceiling in the final API command that we use. Anyway, today I'm going to be using Revit 2022 and also Dynamo 2.10, as comes with Revit 2022 on release. And that's pretty much it. No custom nodes required, just a bit of Python. And hopefully you're all using Revit 2022, because obviously it's not going to work before this. So don't leave comments asking how you can do this in Revit 2020, 2019, etc. You just can't. It is what it is. Anyway, let's jump in.
Okay, so we should probably begin by identifying the problem that we're dealing with here. So whilst you can create floor by outline, type and level in many versions of Dynamo, one problem is if you run into a room like this, which has an outline, but it also has an internalized outline as well. Now you might think these aren't that common, but they really actually are very common. For example, if you're working on an office floor project and you've got a core in the middle of an office floor. This happens a lot, and as a result, we can really struggle to create floors based on rooms, or maybe just the floor plate itself based on a building shape plus a core. So in this case, we're going to be taking the room finish boundaries and trying to generate floors that actually contain internalized curves as well. If I run this current script, notice that if I generate this tile floor with two outlines, it's going to generate the overall floor, and it's also going to generate the internalized floor component as well, which really isn't what we want. We really want it to exclude that element, and we want it to cut out this element from the insides. We really want it to have this internalized sketch boundary, which in this case it does not. So what I'm going to do is just go back before I went and ran this. And this model is available on the GitHub, so if you do need this, just let me know. In this case, actually just go to my GitHub on Aussie BIM Guru. But I'm going to make a new script, and I'm going to start by trying to get the rooms themselves, as well as some properties about their floor finish data, and then align them to some floors that we're going to place inside the rooms. So for example, this room here has a floor finish of tiles. If I go to the properties of my floor types, in this case I have a tile floor, I've given this a matching description of tiles as well. And we're going to use this to align, in this case, the finish to the finished floor we want to place by the room extent. So I do have a similar tutorial on this, but it doesn't capture these internal loops that we can do instead. So it's going to be a pretty long tutorial, so you'll probably want to stick around if you're trying to figure out how to do this, especially the Python component. But we're firstly just going to go and collect the data that we need to feed into our Python node. So I'm actually going to use a new node in Revit 2022, which is room by status. This is a great node. I'm just trying to find it. So rooms by status, there we go. And this will give us just the placed rooms in our model with a valid boundary. This is a fantastic node. Immediately, it's just going to give us the rooms that are working in our model. So we're going to go and collect a little bit of data about these rooms. First of all, we're going to figure out what level this room is placed on, so we know which level to place the floor finish on as well. So to do this, we're going to do a get parameter value by name, and from our placed rooms, we're going to look for the parameter of level. And in this case, we're going to get a name. So unfortunately, this isn't actually a level. I don't believe there's a level by name node, as far as I know. There is one in my custom package, but in this case, we're not going to use it. We're just going to use a more traditional out-of-the-box method. So I'm going to get the category by name node. And I'm going to be getting the category of levels, and I'm going to get all the levels in the model and find out which ones match with the name. So I'm going to use an all elements of category node just to get all my levels. And from these, I'm going to use the element.name node to get the names of all my levels. And I'm then just going to be finding which index these names occur at in the list of levels. So from my list of level names, where does each of these values occur? And I should get an index because it's found a match. In this case, they're all just occurring at the first index, at index 0. So we can see in this case, we're matching to level 0. From this, I can use a get item at index node just to take from my list of actual Revit levels, the corresponding index. And now we've turned that into the true level from Revit itself. So this is sort of the first step. We now have the level that we're placing the floor at. Next, we're going to find out what type of floor we're going to be using. So we're just going to firstly get the element types drop down, and I'm going to be picking from this floor type, because we want to get all our floor types and then find out their description and line that up to the room's floor finish value. So I'm going to use an all elements of type node, first of all. All elements of type to get my floor types. And now I should have one item for each floor type. From here, we're going to get parameter value by name. And in this case, we're going to be getting their description. Remember that we're dealing with floor types and we're getting a type parameter here, so this works. And I can see now that I have concrete, carpet, and tiles. So we're going to be matching carpet and tiles in this case. Of course, if one of these values doesn't exist, you're going to get an error in your script. So make sure that these values are accounted for in your floor types first. I'm going to use another get parameter by name from my original rooms, and I'm going to make another code block, and I'm looking in this case for the floor finish value, which I've populated in the rooms already. And now I should get a list of floor finishes, a mixture of carpet and tiles. Again, I'm just going to index this across the list of floor type values. So we're going to find the corresponding element that should line up. So I'm just going to look for the index node and see if I can find index of. So from my list of descriptions, where do these elements occur? And we should get a match in this case. And we can then get item at index. And now we should successfully have the corresponding floor types as they relate to the rooms themselves. Finally, we're going to get the boundaries of the room. So in this case, I'm going to look for finish boundary, and I'm going to get the finish boundary of each room. And now we should have some preview geometry in Dynamo. So it's important to note that in this case, one of the rooms has more than one curve associated to it. So we should expect to see one of these trigger a list with more than one set of curves. So we can see in the case of item 2 or room 2 in the list of rooms, we've triggered 2 sets of curves. Now, usually what I like to do with these is actually polycurve them together, just so I know that they're going to be in a continuous order. This way, when we try to turn them into a what we call a curve loop in Python, they're going to actually form a valid curve loop. So I'm going to make a polycurve, and then from that polycurve, I'm going to get the underlying curves, in this case, just using the curves node. So if I just turn off these previews, we'll get the exact same number of curves, so it won't look any different, but now we know for sure those curves are definitely all running in a circular order and will form valid curve loops. So at this point, we really have what we want to work with. So I'm just going to move these all just a little bit forward just to get them closer to a Python script. And I might also just save this so that we don't crash and lose it all as demo. And at this point, we're now working with Python. So I'm going to make a Python script block. It's important to note that if you do want the same Python contents in your node as me, go to my GitHub and you'll find this same template available for you to begin from. Noting in this case as well that sometimes depending on which version of Python you're using or which version of Dynamo, you'll get different syntax for how the tabs are managed. So notice in this case, the tabs in my file are managed using 4 dots. So you will have to be careful that you're consistent with either using tabs or 4 dots. In this case, if I do a tab by default, notice it's actually a tab. So what you may wish to do is actually replace some of these elements with tabs, just so you can begin using proper tab formatting. I believe this is a fairly new feature to Dynamo. Now, if you can't see your tabs, another new feature I believe under settings is just to turn on, in this case, show white space characters in Python editor. This is a great feature. I think it's incredibly necessary when you're working in Python, so you can see the number of indentations you're using in various encapsulated statements. If none of that made sense, you probably definitely need to go and have a look at my Python series on my channel, because there's a lot of stuff in there I'm going to be using here without explaining it in too much depth. Anyway, I'm going to add 2 more inputs here. So input 1 is going to be my curves, and remember this is a list of lists, and as well as this, it's a list of lists that sometimes contain sublists. So it's a fairly complex list structure that we're working with. The next thing I'm going to get is, in this case, the floor types, and finally the levels. Now, it's really important to note that for each room, I have a finish and a level. If you want to work a little bit differently, let's say you want to say once you've run out of room finishes, the node keeps sourcing the room finish until it's got a matching number of elements. That's a sort of a different workflow. In my case, this node relies on each room having a finish input and a level input. So I couldn't just put in one level in this case. This is why I've got the level of the room itself. Anyway, at this point, we are going to be going into Python, and we're going to be getting pretty wacky pretty fast, so hopefully you can keep up. But if you're using my Python template from my website, then great. If not, essentially what we are going to need is a few things. Now, I'm just firstly going to delete a few things, so we don't need import sys. I don't believe we need system either, so we don't need system collections, and we don't need proto-geometry, but I think we need most other things. So we do need Revit nodes. We do need Revit services for the transaction and the document manager. We don't need Revit API UI, so we can get rid of that. And we don't need from Revit Autodesk Revit UI import everything. We don't need the UI app or the UI doc, but we do need the document. So you will need to call on the instance of the current document in the model. So hopefully this gives you a good starting point. I'm also going to be using a function, so I'm just going to delete this toList function, but I'm going to be keeping this unwrap list function. What this does is essentially says, if I'm given something that's not in the form of a list, turn it into a list and then unwrap all the elements so that Dynamo can work across them. This is really important if you're working with elements that you need to modify or access using the Revit API. This is why we're unwrapping these elements. But as well as this, I'm turning things into a list so we can iterate across them. In this case, we're going to be using a special form of iteration called zip iteration, which means we're going to iterate across multiple elements at once. In this case, the rooms and also the levels and the floor types at once in sequence. So I'm just going to save. Now at this point, I might just switch to manual so that I'm not trying to generate floors every time I do something. I'm also just going to delete this block at the end, and I'll just keep my transaction block in the middle here. Okay. So now we're going to begin collecting our inputs. First of all, I'm going to be collecting some things here. So I'm going to rename some of these inputs. Instead of element, I'm going to call this thing room set. So this is my set of rooms, but remember that the rooms are actually represented as their individual curve loops. So we're going to be working into this list structure quite deeply. In this case, some of our data is up to 3 levels deep. I'm also in this case going to call on my types, and I'm just going to delete this elements row. And I'm just going to call this types equals unwrap list applied to my first input. So I'm applying a function and also declaring the variable after. I'm also going to be declaring my levels, and I'm going to be unwrapping the second input in this case. So now these are ready to be accessed by the Revit API. I'm then going to build an empty list. I'm going to say that floors is equal to an empty list. So I'm going to open and close the square bracket. And then we're going to begin engaging Revit in a transaction. So we're going to need to modify the model by creating floors. So we do need Revit's attention in this case in order to make this work. We're going to be building a fairly deep iteration statement here. So you're going to have to follow to some degree, but I'm going to try and explain it as I go. But the first thing we're going to do is we're going to call upon a big iteration statement. So we're going to work across our 3 lists of data, and then we're going to have to work deeper into our room lists essentially to get access to those curves at the very bottom, turn them into curve loops, join them together, and feed them into the API statement to create a floor with multiple curve loops. So I'm going to say for, and I'm going to say rm-f-l. So I'm defining 3 local variables to my statement, room, finish, and level. And you can call them whatever you want. You just need to be consistent with what you say from that point onwards. But then I'm going to say in, so I'm doing a for in statement. I'm going to loop. But instead of just saying for I and this, I've got 3 variables. So I'm going to be zipping across these. So I'm going to say zip, bracket, and I'm going to say room set, so my first variable. I'm going to say types, and I'm going to say levels. So these are the actual variables I defined at the start. So we're going to be using these as the lists that we work across. I'm going to put a colon, and I'm going to go to my next line, and I'm going to tab inset. So it's very important that you work with the right number of tab insets so that you can encapsulate each layer of the loop. But in this case, I'm going to just define an empty list called curve loops. Remember that I'm defining this for each cycle of my loop, but I'm using this to store a curve loop to create a floor at the end. I'm then going to iterate at another level. I'm going to say for this case, for curve set D, so for the curve set that belongs to Dynamo in each room. So in this case, I'm referring back to my highest level of local variable. I'm going to inset inside this loop, and I'm going to say, first of all, an empty list. I'm going to say curve set that belongs to Revit, so curve set R is usually what I like to use for those things, is an empty list. So I'm going to fill this list. So in this case, it's going to get a little bit more complex again. There's a few layers of iteration. We're going to say for each curve that belongs to Dynamo in the set of curves that belongs to the room. So we're one level deeper again, so it's getting a bit more complex. We're going to, in this case, append something to our Revit set of curves. And what are we going to append to this? Well, we're going to call on the append statement. And then in this case, we're going to be appending the Dynamo curve, but we're going to be applying a method to this. We're going to say to Revit type. And this will turn it into a curve that Revit can actually interact with. So in this case, it's really important because we're going to build what's called a curve loop, which is an object that's native to the Revit API and how it functions. So we do need to transform this Dynamo curve into something that can be built out of this. So I'm going to go back one level, so outside the building of the list of Revit curves. And we're going to define something called a curve loop. I'm going to say this is equal to, now watch out for the capitalization here, curve loop with 2 capital letters at the front of each word. This is actually the class. So in this case, because I've said curve loop with no uppercase, it doesn't belong to the class. So I am taking a bit of a risk there by defining a variable with a fairly ambiguous name. It's up to you if you want to use something a little bit more safe. A lot of people usually use things with underscores in them because typically class names and methods stay free of underscores. It's up to you. But in this case, I'm just going to say curve loop create. So in this case, I am generating a static method. I'm creating an element from a function. And I'm going to be doing this based on, in this case, my set of Revit curves that I've defined previously. So I'm taking these curves and joining them into an element that the API understands. And then for each of these that I've generated, I'm going to be appending these together. So I'm going to be appending these back into my original list of curve loops that I made a little while ago, a few levels higher. Now I think in this case, I might have encapsulated a little bit too deep, I think. Yes, so I've encapsulated one level too deep. So it should actually look like that. So you have 1, 1, 2, 3, 2, 2 in terms of the encapsulation level, because we're just encapsulating back to our curve loops variable now. So we need to be one level away from that for this to work. And I'm going to be appending, in this case, my curve loop. So if we have more than one curve loop inside that room, we're going to get every single curve loop and put them together into lists by appending them to this original list of curve loops for each room. So it's a fairly deep statement. It's definitely a baptism of fire for anyone that hasn't done iteration before. So if you do have questions about iteration, make sure you go and watch my Python series because it's pretty complex. We're going to go back one level again, and now we're creating our floor. So I'm going to say floor, just FLR equals, and now we're using the important statement floor.create. And in this case, the first variable we'll need is the document, so we're going to use doc, our active document. We're then going to call on our curve loops, so in this case, a list of curve loops. If you're using C++, this would be called an iList in this case. In this case, in Python, it's just a list. And then I'm going to be calling on the floor. So I'm going to call on f, which is my local variable that I instated originally, .id. So I'm going to be getting its ID, which is what this function requires, not the floor itself. I'm then going to get the level.id. So calling on elements by ID in functions is very common in Revit because an ID is not an ambiguous call. IDs are usually unique to an element, so it's a very safe way to instate a function. So I think that's why they tend to use IDs. From here, I'm just going to append the floor that we create to my list of floors so that I can send them out at the back end of the script. And finally, out is going to be floors. So fingers crossed, as soon as I run this, it's just going to work. Hopefully that's the case. I might have made a typo. That is quite common when I write Python because it is very hard. I'm literally watching a script off to the side and trying to match my own syntax, but fingers crossed, it just goes and creates these floors. Nope, I made a typo. So I made a typo in line 44. So I've put something somewhere, curve det d. Okay, so I've just got to do curve set d. So I do love that there's really good debugging in the Python editor. So let's just try it now. Fingers crossed it works. I should just be able to run. Great, it worked, cool. And we should now have a floor for each room. And as you'll see, if you have a look at this floor here, it contains an internal loop. How cool is that? We've been waiting for ages to do this. I'm super excited that this is available as a feature now. Hats off to the developers. You finally listened to us on this one. Thank you. Thank you, thank you, thank you. So there's a lot of things we can do with automating floors in buildings now, which we couldn't do before, just because of this tiny little donut trick. Pretty exciting. Now, what you may wish to do after these floors are created is also offset them by their own thickness, because at the moment they're going to be sitting inside the zone of the floor. Now, for some floors, this might be okay, like a tile finish. You might be setting this down into the floor, and you may, as a result, modify your concrete. But something like, say, a carpet finish is definitely not being set down into the floor unless you're on a very expensive job where they really want a flush finish or they really need a flush finish. And I'd say that no job is that expensive. But if we go to the type properties, we can see there's a property called default thickness. So we're actually going to go and get this property out of each of these floors in this case. So what I'm going to do is I'm just going to freeze down my Python script for now. And from my floor type, I'm going to get a parameter value by name. So I'm just going to expand this again. And I'll just try to find this get parameter value by name. It can be difficult sometimes. There we go. So I'm going to take my floor. I'm going to get the property of default thickness. And now I should have, I think they're all 15 at the moment. But now I know this is what I need to offset my floor by to sit it on top of here. Now sometimes I like to put a watch node in here, just so I can see what's going on as it passes through. So I'm going to pass that through. But what I'm going to do now is I'm going to set a parameter by name. So in this case, the name of the parameter we need to set is height offset from level. How do I know that? Well, in this case, I can just check it by going to element.parameters. Having a look at the list of elements, and I can start to see, in this case, I probably am not going to quite get what I want. I actually need to go to the floor itself. But now if I look at this, I should be able to see the properties available. Now this isn't actually what I want to see. I actually want to see the properties of the floor itself. So what I'm going to do is I'm just going to open up the script again to run. This will probably create a second set of floors, and it has. But what I can do now is just see that the parameter I'm looking for is height offset from level. So once we've made this, we're going to set that to this value. So my value is going to be the thickness of the floor, my input is the floor, and my parameter is height offset from level. I think that's all uppercase. Yep, great. So we're just going to connect that. Now what I'm going to do is I'm going to close my Dynamo script, reopen it, delete all the finished floors so I can run this all at once. And I'll just reset temporary height isolate. And in Dynamo, we should now be able to do it all in one. So if it works, this is pretty cool. So 3, 2, 1, bang. Sweet, look at that. Tile floor, carpet floor, sitting up off the slab finish. I am pretty excited by that. This is fantastic. Now something else you can do is this is a very similar function to ceiling creation now, and because they use the same Sketch API updates, we can really just do the same thing. Now I'm not going to build it right now, but if you did have the ceiling finish in each of these, in fact maybe, you know what, bugger it, let's do it. I wasn't going to do it, but I'm going to do it. So I'm going to take all these ceilings. I'm just in this case going to call their ceiling finish plaster. And I'm also just going to go and check my ceiling types and make sure I have at least one type. That description matches that. Feel free to jump ahead if you don't want to see this, but I want to do it. So I'm just going to save this as a new script. And I'll just call this demo 2 because naming, who needs it? So now instead of floor type, we're going to get our ceiling types. Great. Ceiling type. Everything else should be the same, except we want our ceiling finish this time. We're getting the level of our room, that's all fine. Now at the moment, the way that we want to set the properties of the height of these rooms is probably different. So at the moment, our ceiling in this case probably should actually hide itself based on its limit offset. So in this case, let's say its limit offset is 2700. Now we can just go and instead of retrieving the default thickness, we're going to go back to the rooms themselves. And in this case, we're going to have to find that parameter. I think it's called limit offset. I'm just going to go limit offset and see how we go. I'm going to take a punt. And instead, I think nearly everything else is how we want it to be. Ceiling type, description. I think the only thing that we need to change now is, and I'm pretty sure this is the only change, we just do ceiling.create. Now I could go and rename floors, ceilings, etc. Who cares? It's all in the Python node. I think this should work. If it does, I'll be pretty excited because it shows how similar these methods now are, which is really what the Dynamo team was aiming for. The last thing we might want to do, and I just need to check the name of this parameter when I place a ceiling, is what the height offset parameter is called. It's also called height offset from level, so fingers crossed it's also called that in Dynamo. So I'm just going to go into demo 2, and hopefully we can just run. Check it out. We have ceilings, almost the same routine, and the ceiling has also cut itself out. So I'm really excited by how easy these are to work with now. All you need is that basic Python script and you're off to the races.
So there you have it, floors and ceilings with holes created in them as well, using Dynamo and the Revit API in Revit 2022. I hope you found this useful, and it also maybe taught you a few things about using various types of iteration and encapsulation as well. I know it was a pretty complex Python script, so if you are looking for just the nodes themselves, I have actually added them to my custom package, Crumple, and you can download them from the package on the package manager. Again, reminding you these will only work in Revit 2022 and beyond, because the API methods don't work in the same way in older builds. But at the same time, hopefully they help you in just automating your general workflows. Anyway, if you're not already following and subscribing to the channel, feel free to do so. And I look forward to seeing you in future similar videos. Thanks. Take care. Bye.